So, machine learning, it's a term you hear everywhere, right? But what does it actually mean? It kind of feels like this mysterious black box. Well, you know what? Today, we're going to pry that box right open. We're going to look inside and see how a machine really learns. And you see it every single day. Ever stop and wonder how your email just knows what's spam? Or how your favorite streaming service queues up the perfect next show? It's not magic, I promise. It's something much cooler. It's a total shift in how we talk to computers. So, to really get what's going on, let's compare the old way of doing things with the new world of machine learning. Okay, let's go back to that spam filter. On the left, you've got the old school, traditional way. A programmer sits down and painstakingly writes out every single rule they can think of. If the email has free money, bam, it's spam. But you see the problem, right? You're always playing catch-up. Now look to the right. The ML approach flips the whole thing on its head. Instead of giving the machine rules, we give it examples. We show it thousands of emails we've already marked as spam or not spam, and just tell the machine, hey, you figure it out. It learns the patterns all on its own. And that right there, that is the single biggest aha moment of this whole thing. Get this, in traditional programming, a human writes the logic to get an answer. But in machine learning, we give the machine the data and the answers, and the machine itself discovers the logic. It literally writes its own program. So cool. Okay, so I know what you're thinking. How does a machine actually discover anything? What does learning even look like for a computer? Let's peel back the layers and see how it works. Well, it all starts with data. Lots of it. Let's use a super simple example, predicting house prices. So you've got this big spreadsheet of houses, right? That entire spreadsheet, that's your data set. Now, just one row in that sheet, say one single house, that's a sample. The stuff we already know, like the size or the number of bedrooms, we call those features. Think of them as the X variables. And the one thing we're trying to guess, the price, that's our label or our Y. That's it. The entire game is just figuring out the hidden relationship between X and Y. Okay, before we move on, I have to tell you about the golden rule. The number one most important rule in all of machine learning. You ready? You can never, ever evaluate your model on the same data it trained on. Think about it. That's like giving a student the answers to the final exam before they take it. Yeah, they'll get 100%, but did they actually learn anything? Of course not. So how do we stop our model from cheating? Simple. We split up our data. We usually take a big chunk, maybe 80%, and call that the training set. This is the homework. It's what the model gets to study and learn from. Then we take the other 20% and lock it away in a vault. That's the testing set. This is the final exam. The model has never seen these questions before. And how well it does on this set, that tells us if it really understands the subject. And this whole idea gets at a really important concept called overfitting. It's when the model doesn't really learn the homework, it just memorizes it. It gets a perfect score on the training data, looks like a genius, but then you give it the final exam, the test data, and it totally bombs. Why? Because it never actually understood the underlying concepts. All right, so we get the basic process. Now, let's talk about the different kinds or flavors of machine learning. You can think of them like different tools in a toolbox. You wouldn't use a hammer to saw a board, right? Same idea here. First up is the one you'll see most often, supervised learning. And the name kind of gives it away. It's supervised because we're like a teacher standing over the machine's shoulder. We give it data that already has the correct answers, the labels. It's like giving it a stack of flashcards with the question on the front and the answer on the back. And this is perfect for solving two main kinds of problems. The first kind is how much? Like predicting a house price. That's called regression. The other kind of problem is which category? Is this email spam or not spam? Is this picture a cat or a dog? That's called classification. Okay, our next tool is the total opposite, unsupervised learning. This time, there's no teacher, no flashcards, no right answers. We just dump a whole bunch of unlabeled data in front of the machine and basically say, here, go find some patterns, tell me something I don't know. So when would you use this? Well, it's amazing for finding hidden groups in your data. That's a technique called clustering. Imagine you run an online store. You could feed all your customer data into an unsupervised model, and it might just pop out these natural groups you never even thought of, like weekend shoppers or big-ticket buyers. It finds the structure for you. And finally, our third flavor is reinforcement learning. And this is a whole different beast. You don't start with a giant data set. Instead, you have an agent, like a little robot. And it learns purely by trial and error. It tries something, If it does something good, it gets a reward. If it does something bad, it gets a penalty. The baby learning to walk analogy is perfect. There's no instruction manual, it just keeps trying and falling until it figures it out. So what's this good for? Well, this is how AI programs like AlphaGo learn to become the best Go players on the planet, just by playing against themselves millions of times. It's also at the heart of robotics, teaching a robot how to pick up an object or navigate a messy room. Okay, so we've got the theory down, we know the what and the why, but what about the how? How do coders actually build this stuff? Well, in the real world, it almost always comes down to the Python programming language and a handful of incredibly powerful libraries. Let's meet the big three. First, you've got NumPy. Think of this as the math engine. It's the workhorse that does all the heavy-duty number crunching, super fast. Then there's Pandas. This is your data engine. It lets you handle data like you would in a spreadsheet, but with way more power. And finally, Matplotlib. That's your plotting engine. It's how you turn all those numbers into charts and graphs so you can actually see what's going on. All right, this is the moment we've been waiting for. We've got the concepts, we've got the tools. Let's put it all together and go from abstract ideas to actual working code that makes a prediction. Now, a library called scikit-learn is the absolute king here. And what's amazing is it boils the whole process down to a simple, repeatable, 5-step recipe. It's beautiful. 1. You import the algorithm. 2. You instantiate a model. 3. You arrange your data into your features, X, and your label, Y. 4. And this is the big one. You fit the model. And finally, 5. You predict on new data. That's it. Every time. And look, here it is. This is that 5-step plan as real Python code. It's not scary, I promise. See step 1? We import our tool, linear regression. Step 2, we create our model. Step 3, we set up our X, the house sizes, and our Y, the prices. And then step 4, the magic line, model.fit. That's it. We just told the computer, learn the relationship between these numbers. And just like that, it's trained. So now for the final step. We ask our brand new model, hey, based on everything you've learned, what do you think the price of a 150 square meter house would be? And the model spits out an answer, 1,595,000 Moroccan dirhams. It took all the patterns it found and made a highly educated guess. Just like that, we went from a puzzle to a real-world prediction. And really, that brings us back to the core idea of this whole revolution. It all comes down to asking one simple but incredibly powerful question. What if we stop trying to write the rules for how everything works, and instead we just show the data and let the patterns speak for themselves? That shift in thinking, that is the real power of machine learning.